second row, third row, like that. How many number of transformation uh, random variables are there? So that much of matrix we will get. That is size is depends upon the random variables. Now, if you want to write this equation from this matrix form, suppose if you want to write for x1 is equal to, you will get like bi1, bi2, bi2, y2 plus and so on, bin, yn. Generalized equation if you write. Now, that is, uh, we are going to be write this inverse operation for generalized case like xi, I indicates here takes 1, 2, 3, so on, and bi, bi1, y1, bi2, y2 plus like that. Similarly, wherever we have this random variable xi, it is going to be divided with this mean xi minus xi bar is equal to bi1, y1 minus y1 bar, bi2, y2 minus y2 bar, and so on, bin, yn minus yn bar. And we know whenever there is a inverse transformation, so it is dxi by dy I, dy is equal to d by dyj inverse transformation, that is going to be right bij. So this a determinant matrix, we are going to calculate T inverse, that is J is equal to determinant of T inverse, that is equal to 1 divided by T. Now already we have seen this correlation of any two random variables, that is a Cxi xj is equal to expected value of xi minus xi bar into xj minus xj bar. Now this same equation, whatever we have this linear combination of transformation random variables, now we can write, we have a formula for xi, that formula here we can replace with this bi1 into y1 minus y1 bar and linear combination of this. So like that, we can frame a generalized mathematical equations. So the generalized mathematical equations are k equal to 1 to n bik and m equal to 1 to n bjm and expected value of yk minus yk bar into ym minus ym. Now finally, this cxi cxj is equal to k equal to 1 to n bik, m equal to 1 to n bjm cyk ym. That is correlation between two random variables here. So from this, we can give conclusion. This cxx, cxi, cxj is the ijth element of covariance matrix, and similarly, this the kth element of this cyk or kth element of the covariance matrix of cy. Now this bik is the kth element of T inverse. So finally, if we form a covariance matrix from this, we can write cx is equal to T inverse into cy T transpose into E inverse. So or cy is equal to T into cx into T transpose. So the inverse of cx is cx inverse. If we write the inverse, whenever there is a T inverse, it can be modified as a T. Cy is modified as a cy inverse, and T inverse is modified as T. So then you can calculate this cx inverse. This cx inverse we are going to be obtained Cx inverse is going to be obtained is equal to this T transpose into T is going to get T square and Cy into inverse. So finally, this is going to be right in density function, Gaussian n random variable density function. So that is going to be like this. Density function formula is like this. So it is about linear transformation of random variable. So somewhat lengthy analysis is there, but anyway, we have an idea about Gaussian random variable. From that Gaussian random variable, single random variable, that concept we are extending into linear transformation of Gaussian random variable. The simple idea is a set of random variables we are going to be converted into new domain, and then again we are going to be inverse operation, and we will get the original transform. So whenever the random variables are increases, so we are going to be write like a matrix form. So that is somewhat complex mathematical equations. But if we concentrate on this, we can easily obtain this equation. The mathematical form, the theoretical case, it is somewhat difficult. But whenever if you go for problems, there may be some two random variable case, we can easily understand. Thank you. We will see the next.